Good morning, everyone. Today we will see the basics of spatial filtering. We know the spatial domain consists of mainly XY coordinates, and we are placing various pixels in the spatial domain. And the spatial domain enhancement is mainly based on the pixels in the same range. That is, the neighborhood operations are taking place in the spatial filtering. Mainly, there are mainly two types of spatial filtering. One is linear spatial domain filtering, and other one is non-linear spatial domain filtering. We will go through the linear spatial domain filtering and non-linear spatial domain filtering in detail. We have already gone through what is a filter and how does a filter work on an image. That portion is already covered. First, we will see the smoothing linear filters. The smoothing linear filters is main objective of the smoothing linear filters is to remove the minute details from an image prior to the object extraction. It also bridges the small gaps in lines or curves. Main smoothing filters include average smoothing, Gaussian smoothing, and adaptive smoothing. And the main linear filters are average linear filters, and order statistics are non-linear filters. First, we will see the average linear filters. It is also referred to as low-pass filter. The idea of the average filter is to replace the value of every pixel in an image by the average of the intensity levels in the neighborhood defined by the filter mask. The application is for the noise reduction. And edges are also the important part of the image uh, uh, applying this average filters in order to get the effects of blurring of an image. This is the 3x3 averaging filters we are using. This is a standard average filter we are using, that is 1/9. 1/9 is by the addition of it is a 3x3 matrix, and we will get a 9 cells in this 3x3 matrix. So the average is 1/9. The weighted average filter means in the we are placing pixel values greater than 1 in this image values, and the middle one has the highest priority. Here it is an example of an average box filter. The application of average filters by different iterations. Box filter is nothing but it will give the spatial coefficients will be same. That means the coefficients of the filter will be same. That is the box filter. A spatial average filter in which all the coefficients are equal is known as box filters. And the weighted average filter, I already said, the middle cell is given the highest priority, and it will reduce the blurring during the smoothing process. Now we will see how to apply a standard average filter in an image. Here we have an example. To apply the standard average filter for the pixel at the 3-3 position. A row starts with the 1 and column is also starting with the 1. So 1, 2, 3, and our filter means we are choosing this is the 63.3. This is our value. We have to replace this value using standard average filter. And we have given a filter, standard average filter, that is 1/9 into 1, that is the mask we have given. And we are placing this filter above this value. That is, this is how we are placing this filter. This is how we are placing this filter. And here we are multiplying the coefficients of filter with the coefficients of the pixel. That is 20 into 1 plus 80 into 1 plus 100 into 1 plus 30 into 1 plus 60 into 1 plus 10 into 1 plus 30 into 1 plus 70 into 1 plus 40 into 1. Here we are giving the 1/9. This is a standard average filter we are using. So that is 1/9. and we will calculate this value. This is how the average filter is using. We will see another example. Here we will apply the standard average filter at the pixel point 1, 1. Here 1, 1 is the point 20, 20. We have to place this standard average filter on this one. That is, the middle of this filter will be placed above 20. So the rest of these portion will be outside of this original image, and these portions will be also outside the original image. So we have to pad zeros in the column wise and row wise. How many number of zeros you will be added to rows? Same number of zeros you should add to column wise also. So here we are adding zeros, and we will place this filter with the center as 1. This is center, we will place this. And we will calculate as 0 into 1 plus 0 into 1 plus 0 into 1, 20 into 30 into 1, 20 into 1 plus 30 into 1, 20 into 1, 0 into 1, 0 into 1. Likewise, we are applying the standard average filter. Next, another, we have given the weighted average filter. So 1 by 16 into the weights means the addition of these numbers by 1 by 16. 1, 2, this filter will be applied in 2, 3. Position is 2, 3. 2, 3. That is this 80. 2, 3 is 80. We have to place this filter above this middle 4 will be here. 1 will be here, 2 will be here, 1 will be here, 2, 4, 2, 1, 2, 1. The coefficients of the weighted average filter should be multiplied with the coefficients of the pixels. So 1 by 16 into 30 into 1, 50 into 2, 80 into 1, 20 into 2. And likewise, we are calculating the standard average filter. This is how we are applying the average filters. This is a linear filter we are using for blurring purpose. The next one we will go to the non-linear smoothing filters. The fine example we have seen for the linear filters is average filters. The next one is order static non-linear smoothing filters. And the response of the filter depends on the ordering or the ranking of the pixels in the image, and replacing the center pixel value with the value determined by the rank result. The most commonly used smoothing non-linear filter is median filter, and other two are max filter and min filter. The median filter is mainly used for the purpose of removing impulse noise. Impulse noise means the middle one is 0, the rest of the pixels will be 1. And also salt and pepper noises will be removed using the median filter. And the filter replaces the value of a pixel in the image by the median of the gray levels encompassed by the filter, provide excellent noise reduction compared to linear smoothing filters. It causes less blurring in the image. It will give more brightened pictures after this filtering. We all know about the median value. We are familiar with the median value. Median means if we have 10 numbers or 9 numbers, we have to sort these numbers and we will get a middle value. That is the median. Same property is applying in this. We can look at an example. Consider the following 5 by 5 image. We have 20, 30. This is an image. We are applying a 3 by 3 median filter on the shaded pixels and write the filtered image. Now let us first we have to go through the two. We are considering 255. So in this image, first we have to, this is a 5 by 5 image, but the filter is 3 by 5. So we have to apply the 3 by 3 matrix 255. We have to place this filter above this. So the 255 is the center and the rest of the pixel is given. And these all neighborhood pixels will be arranged in the increasing order of their numbers. That is, we have 30, 20, 80, 70, 30, 30, 25, 250. So 20, 25, 30, 30, the order in the increasing order. So you have to find out the middle value of these numbers. And you have to replace 255 with the 30. We get the middle value as 30. So you have to replace it with the 30. Again, next number is 70. 70 should be replaced as like we say, 3x3 median filter is applied here. And sorting is performed. And 80 is replaced in the case of 70. It's very simple. We have which filter you have given that apply on this and find out the sort that particular neighboring pixels and find the median value and replace it with the original image. And this is how we will get this filtered image. Finally, we get the filtered image 20, 30, 30, 80, 100. Next is max filter. Max filter to find the brightest points in an image. To find the maximum value in the area composed by the filter. It reduces the pepper noise as a result of max operation. We know the color of the pepper is black, so it will be reduced as a result of max operation. Max operation find the brightest points in an image. We have given the metrics like this, that this is the image. Certain elements, certain zeros are padded. And we have given a 3x3 filter 1, 2, 2, 1, 1, 1, 4, 2, 4, 0. And it is given in this part 1, 2, 2, 1, 1, 1, 4, 2, 4, 1. And you have to find out the maximum value of this, which is the maximum value. And you have to replace it with maximum value should be replaced. And you have to slide to another window. You have to slide to the next and again find the maximum value, then replace it with the maximum value. How to find the maximum from the window? Here it is 4 and it should be replaced by 4. And similarly find the maximum by sliding the window on the whole matrix. The output of B, it should be like this. The whole matrix is slided. Min filter, you have to find the darkest points in an image. You have to use the min filter. Find the minimum value in the area encompassed by the filter. And it will reduce the salt noise. Salt noise means you have to reduce the intensity of white noises using this min operation. Same operation is done using min operator as like the max operator. So this is all about non-linear filters. In linear filters, we are mainly using average filters. And in non-linear filters, we are using median filter, max filter, and min filter. Thank you. Thank you.